Good morning, good afternoon, good evening, or good night. As promised, this is one of the videos showing a manipulative that helps with algebra. It is algebra blocks, as you can see, the algebra coordinate mat. Let me introduce you to the characters. The green here is our 1 by 1, so officially it's our one piece. Our yellow is our x. It is 1 wide and x long. Our orange is our y. It is also 1 wide and y length long. Our yellow square is in fact a square. It is the square of two x's. So x times x gives us x squared. We also have y squared. And a fun little piece, an xy. Alright, as a quick review, we're going to look at how we can use this to do some multiplication. We're going to start off with a fairly simple problem. X plus 2 times x plus 3. The idea is to make rectangles and fill in the pieces. So x times x, of course, is x squared. X times 1s are x's. And then 3 1s times 2 1s. Okay, we can remove our original multiplication problem, our x plus 2 and our times our x plus 3. And we can see that we get x squared plus 1, 2, 3, 4, 5 x's. So x squared plus 5x plus 6. Now this mat is set up with positives and negative quadrants. Unlike the algebra tiles, which use different colors to denote positive and negatives, it uses quadrants. So let us look at a quick problem of x minus 2 times x plus 2. If we look at this, we notice we have to go and create our x squared. Now we also have, as we did x times negative 2, 2 times x, and 2 times negative 2. Again, we remove the original pieces. And now we can go about combining like terms. X squared does not have a like term to combine, so it stays by itself, x squared. We have minus 2x plus 2x. So we can get rid of our 2x's. And we are left with x squared minus 4. Alright, so that was just that quick review. What we're really interested in today, as you notes that you got earlier, is on factoring. And our first problem that we're going to factor is going to be 6x minus 2. So here's my 6x. And here's my negative 2. Remember, we're trying to keep it in a perfect rectangular shape. Even though we do have the gaps for where the part's going to go. Now we have to determine how we got this multiplication. All right, So, how did we go about it? Well, it looks like we can match up our bits. So we know there had to be 3 x's. And we can see here that it's in this column of 2's. So if we have 2 over here and our 3 x's, it looks like we're getting close, but we haven't accounted for this -2 yet over here. We have now accounted for 3 x's times 1 times 2. But we have to count for these. And how do we have that? Well, if we have 2 here, then we would have needed 1 down here. 2 times -1 is -2. And we now look at it and go, okay, 6x minus 2 can be factored into 3x minus 1 times 2. And that's factoring by removing a common factor. Now let's go ahead and consider a slightly harder question, such as x squared plus 4x plus 3. So first we need to have our x squared plus 4x plus 3. Now, of course, we can have these done different ways. We've got to try to find the way in which it makes a perfect rectangle. So there is a little trial and error as you place your pieces about. All right, so as I said, it's a little bit of figuring it out. And there we go. That looks like a nice perfect rectangle. So now we got to go about trying to pull it apart. We knew x squared. The only way to get an x squared is if we had an x in both of the original pieces. So we have got that. In order to get these 1x pieces, we need to multiply our original x by 3. So here we have x plus 3. And we're looking up, and we see another x on top here. Multiply the x by 1 to get that. And 1 by 3 gives us these 3. And we've now successfully factored our original of x squared plus 4x plus 3. And it factors into x plus 1 times x plus 3.